Hi guys, it's me again, Kenneth, and I'm making free videos that teach quality engineering step by step so that you can build real skills without paying expensive courses. So we've covered customers extensively. Now we turn to the other side of the relationship, which is the suppliers. And now we'll close today with something different in character, the specific name, the barriers that stop quality initiatives from working at all, regardless of how good the tools are. So here's the roadmap. First is the short history of how supplier quality management evolved from a wasteful inspect everything model into today's standard-based system, including the specific standard that shape different industry. Second, the three core techniques, the audit sampling, inspections, and surveys, including the different types of each. Third, we'll go deep on the supplier survey process itself, since the topic provides generally, in detail, like how to prepare, what checklist categories to use, and how to run the opening conference, plan tour, and closing conference, and what the final report needs to contain. Fourth is the supplier evaluation, the actual rating formulas used for quality delivery and overall weighted score. Fifth is the supplier improvement and risk management. And finally, we pivot to the 12 specific barriers to quality improvements identified to a real study of TQM or total quality management companies ranked in order of importance and how organizations actually overcome them. So let's start with the history because the current system only makes sense once you understand the wasteful model it replaced. So many years ago, companies worked under a simple assumption. Engineers design products and specified requirement. Suppliers provided materials, manufacturing built the products, and the quality control inspected the product after it was made, specifically to ensure quality. So this topic is directly about verdict on the approach. It was inherently wasteful. Quality was being checked for at the very end, after all the cost of the production had already been sunk in a potential defective product. So since the 1940s, the use of quality standard for suppliers has gradually evolved into a system that ensures quality products meet requirements with only a limited amount of inspection by quality control personnel, catching problems earlier and more cheaply than a pure end of line inspection model ever could. So several standards contributed to this evolution. The MILQ 9858 and the BS 57550, industry-specific standards starting in the early 1960s, and the ISO 9000 family. So which we'll cover in the more depth in the chapter 2 of the ASQ CQE. So two industry-specific examples are worth knowing by name. So in the automotive industry, the Automotive Industry Action Group, or the AIAG, manages the production part approval process manual, so published in 2006, a standard supplying list of several specific elements of manufacturing process to ensure suppliers meet their customers' requirements, including things like design records, change documents, FMEA, and control plans. So in the aerospace industry is AS9102B from 2014 and managed by the Society of Automotive Engineers, or SAE. So detailed requirements for the first article inspections, a method for documenting the requirements of aerospace parts between the customers and suppliers. So there's no ambiguity about what was agreed to. The bigger cultural shift underneath of all this is the quality assurance personnel now spend greater effort ensuring that the quality is built into products and not just conformance is achieved during production. So rather than just inspected for afterward. The lines are becoming more blurred as Six Sigma programs help everyone in organization becomes concerned about the quality and defect prevention. So the same team cooperation and close communication used internally are now being applied to suppliers relations too. So the overall goal, citing the Johnson and Weber 1985, is to ensure purchase items confirm the two requirements without needing extensive inspection on receipts, and the continual improvement is generally practiced, not just claimed. So at the superficial level, surveys, audits, and inspection all have the same underlying goal. They provide internal or external customers with a degree of confidence. And this topic is carefully to state the degree of confidence, not absolute assurance. The quality of the product or process is what it should be, but each of these three tools has its own distinctive characteristic, and conflating them is a common and costly mistake. A useful way to distinguish survey from audit, which we'll expand this shortly, is timing. A survey is typically conducted prior to a formal contractual relationship with a supplier. So while an audit is typically performed after the formal relationship is already in place. So in other words, a survey helps you to decide whether to work with a supplier at all. So while an audit checks in on a supplier you've already committed to. So inspection is different in kind from both. It's defined a process of measuring, examining, testing, gauging, or otherwise comparing a unit with the applicable requirements. So it's about the actual physical product or lot, not the supplier broader system or process. So we'll cover inspection's own subtypes, including the important distinction between 100% inspection and sampling inspection in a moment. So keep this three-way distinction in mind as we go deeper on each. So survey is a pre-contract and broad, audit is a post-contract and systematic, and inspection is about the tangible product or the lot itself, whether performed at 100% or via sample. So ISO 9000 2015 give us the formal definition of an audit, a systematic, independent, and documented process for obtaining objective evidence and evaluating it objectively to determine the extent to which the audit criteria are fulfilled. The fundamental elements include determining the conformity of an object carried out by the personnel who are not responsible for the object being audited. So that independence requirement is generally important since auditing their own work introduces an obvious conflict of interest. It's also worth noting that audits of a supplier system or process can only be performed at the supplier's facility, while audits of a supplier product may be performed at either supplier's or the customer's facility. So there are three specific types. A system audit, citing Russell 2013, is a documented activity performed in the management system to verify through examination and evaluation of objective evidence. So that applicable elements of the quality system are suitable and have developed and documented and effectively implemented in accordance with specified requirements. A system audit examines everything within the system, the process, products, services, and supporting groups like purchasing or customer service. It's the broadest of the three audit types. A process audit is an analysis of elements of manufacturing or service delivery process, as opposed to something like um, calibration process or supplier qualification, and it's done ensuring the process are working within the established limits. Unlike the system audit, a process audit covers only a small portion of the total system and therefore often takes less time to complete. So Russell precise paraphrasing is worth quoting. A process audit checks the adequacy and effectiveness of the process controls, especially by procedures, work instructions, flowcharts, and training and process specifications. A product audit, again citing the Russell 2013, is an examination of a particular product or service, hardware, process material, or software, to evaluate whether it conforms to requirements, specifications, performance standards, and customer requirements. So here's a generally important clarification for this topic mix. Products Product audits are performed after the product has passed the final inspection. So this method should not confuse with the inspection itself, which connects the accept or reject decisions on the product or lot. So in a product audit, the product is examined in terms of form, fit, and function after it has already passed inspection. So put another way, the product audit reviews that everything was supposed to happen to the product actually did happen. So verifying the system and process. So not just the part. Audit can be also used to assess change control and configuration management. A product audit ensures the configured products meet specification, while a process audit on the configuration process itself verifies that the process is appropriate and maintained. Inspection, again, is the process of measuring, examining, testing, gauging, or otherwise comparing a unit with the applicable requirements. It's worth understanding that the analog for this topic. So sampling inspection is somewhat comparable to surveys and an audit in spirit. While 100% inspection is somewhat comparable to production line operation, since every single time is subjected to it. 100% inspection is required in certainly high critical process and in process that produces unavoidable defects. So this topic specifically example is a semiconductor fabrication where even a mature process will produce some defective units by its very nature. But here's an important practical caveat. Generally, 100% inspections done people are not completely effective human attention simply degrades over long a repetitive inspection runs. So as a result, in today's industrial environment, 100% inspections are nearly always automated rather than performed manually. Beyond 100%, there are several distinct types of sampling inspection worth knowing. So acceptance sampling is something where decisions are made to accept or reject a product or service based on the results of the inspected samples. The foundation form of sampling inspection. So skip lot inspection is an acceptance sampling plan in which some lots in a series are accepted without any inspection at all because the sampling results for a stated number of immediate preceding lots meet stated criteria. Essentially, a track record of good lots earns a temporary pass on inspecting every single lot for this. So the specific methodology is detailed in the American National Standard, or the ANSI ASQ S1 2012. So incoming inspection is the inspection of purchased parts at the customer's facility after the parts have shipped from the supplier, specifically to ensure supplier compliance with the specification and contractual agreements. Source inspection flips the location. It's the inspection of purchased parts of at the supplier's facility by a customer representative again to ensure compliance with the specification and contractual agreements, but catching any problems before the parts ever ship rather than after they arrive. So choosing between incoming and source inspection is often the trade-off between cost, trouble, and how much risk a customer is willing to accept in shipping first and verifying second. So let's go deep on the supplier survey since the topic provides a genuinely, a specific, almost a procedural detail here. First, the definition. A survey is a broad overview of a supplier system on and or process used to evaluate the adequacy of a system or process to produce quality products. So citing Lafort 1986, a system surveys assesses whether the supplier has appropriately controlled systems that will adequately prevent the manufacture of non-conforming products. A process survey evaluates whether a supplier has control in place, proper tooling, equipment, inspection, and so on, to ensure that the process will manufacture quality products. The primary purpose of surveying a supplier or potential supplier is to ascertain three things. Number one is adequate financial resources, evaluate purchasing, and adequate manufacturing capabilities, evaluated by manufacturing engineering, and adequate quality systems, like evaluated by the quality assurance group. Although a supplier survey and a supplier audit can look almost identical in practice, the distinction usually drawn is timing. A survey happens prior to a formal contractual relationship, while an audit happens after one is already in place. Preparation matters enormously here. In preparing for the survey, the team leader should gather as much as information about the supplier. The purchasing agent can provide the copies of the supplier's annual report, credit investigation, done and branch states reports, like internet searches and their certifications. A facilities and equipment list should be reviewed by the manufacturing engineering, and the supplier's quality manual must also be reviewed before the survey even begins. The survey team itself may be made up of members of purchasing, manufacturing, and quality control, plus various specialists in areas like NDT or the non-destructive testing or product design. At times, the team may consist only the quality professional alone. In that case, the purchasing agent has to usually evaluated the supplier financial status separately. Critically, the team must meet before ever arriving at the supplier's facility. So this pre-survey meeting exists to accomplish four specific things. Ensure all team members agree on the theme and purpose of the survey. Ensure roles and responsibilities are understood by everyone. Draft a preliminary survey agendas and select the team leader. The team leader also has to handle unglamorous logistics, verifying the supplier current address, the name of the host contact, and the correct time and date. And it's often appropriate to advise supplier of the proposed agenda in advance. So letting the supplier representative actually prepare for visit rather than ambush it. So to quantify the results of a survey, rather than leaving a vague overall impression, there has to be a formalized approach for collecting data and evaluating the systems observed. The primary method is for the survey team to use a checklist to record results, and this checklist commonly cover both the procurement and the manufacturing quality aspects of suppliers' organization. The manufacturing in the quality checklist is typically broken into 10 categories shown on the screen: drawing and specification control, purchase material control, measuring and test equipment control, process control and product acceptance, material storage area, packing, shipping, and record retention control, quality program management, statistical process control, a strength summary of the system survey, a corrective action survey of the system survey, and finally a summary report. So this topic notes that this category may be expanded as needed and points to Lafford 1986 for a fuller amplification of each one. The supplier procurement checklist is typically broken into four categories: a general information, product information, facilities and equipment information, and sales, shipping, and payment information. Like the manufacturing quality list, these categories can be extended and expanded as the situation requires. So one refinement worth highlighting is the use of scoring, numerical, alphabetical, or some other regularly sequence scale in a checklist further enhance the quantification and validity of the judgment made during the survey. And here's a genuinely useful practice. Many professional evaluators prefer having the supplier also score a copy of the same checklist themselves, which lets you directly compare the customer's viewpoint against the supplier's own self-assessment. A mismatch between two is itself valuable information about how well the suppliers actually understand its own gap. So now let's talk about how actual on-site survey day unfolds. Like in the sequence, it like for this topic, it begins opening a conference described directly as a get acquainted time. Like the survey team members explain why they're there and what they're going to attempt to do, and in a general way the results they expect. So each team member explains their role both in the survey and in the customer organization, and the team leader briefly explains the nature of the customer's products or services. So this matter because, citing the vendor Vendy Technical Committee from 1977, it is essential that all levels of supplier management understand the scope and purpose of the survey, not just people directly hosting the visit. So each supplier representative present should likewise explain their own role, describe the products manufactured, and give an overview of the company and its system. The opening conference is also a good moment for the survey team to brief the supplier on the specific development products and it's intended to be purchased. So next, a brief plant tour acquaints that survey team with the supplier overall operations, after which members proceed to their respective assigned areas for detailed evaluation against the checklist, recording points scores as they go. So here's also a generally important for a procedural rule. It is imperative that each area be evaluated in the actual area itself, so not in the conference room or the manager's office. The reasoning is precise by being physically present in the appropriate area. Verbal statements of compliance and quality procedures can actually be verified by witnessing the action performed rather than just taking someone's word for it. If the survey team finds anything negative, they should discuss it with the supplier escort who was present at that time to reconfirm that the facts before closing the conference with the supplier top management. So before that closing conference, the survey team should meet privately to compile a report for the conference. Explicitly not the final report yet, so during the closing conference itself, the team leader reviews each category, expressing both the strengths and the weaknesses observed. And at this point, it may be possible to estimate the corrective actions required for any deficiencies not already addressed. So this chapter is emphatic about the for this team. The closing conference must be kept on a positive note with a win-win attitude on both sides, which generally challenges the team's leaders' communication. The team leader should focus on the major deficiencies first. If any detailing appropriate corrective actions, followed by only a brief mention of minor deficiencies observed. So there's a real warning both repeating all can be lost if the survey team presents an extensive list of minor observations with a few major deficiencies intertwined. So burying the important findings in the sea of nitpicks undermines the whole exercise. The end product of the survey or the quality program evaluation should be an understandable final report. A good report effectively communicates the findings using the original observation to support the conclusion and must be an honest, objective summation of the team's effort, not a sanitized or diplomatic, account. So this topic specifically, six things the report should detail, show on the screen. So one is all individual present and their correct titles. A basic but easily overlooked accuracy requirement. Two is the areas evaluated. Three, any major deficiencies requiring written and corrective actions. Four is any minor deficiencies. Five is a summary that states that the actual conclusion. For example, the approval, the conditional approval, where the corrective actions should be addressed, or outright disapproval. And six, a closing statement expressing the appreciation for the supplier assistance and cooperation. A relationship preserving touch even when the findings themselves were difficult. So there's a generally practical tip worth repeating. If at all possible, the survey team should leave a draft copy of the survey report. So with the supplier before leaving the site, doing doing so means any questions can be cleared up immediately, face to face. So it's much more difficult to clarify misunderstanding when a copy of the final report only arrives a month or more later. So by which point memories have faded and have the chance for quick, informal clarification has passed. Finally, survey follow-up. So this is carried out specifically to ensure that a supplier who did not qualify at the time of the survey visit has since taken the satisfactory corrective action. The customer has to judge whether an actual follow-up visit is warranted or whether a report from the supplier accompanied by the suitable documentation of the corrective actions is adequate on its own. A judgment call based on the severity of what was originally found and how much trust has already been established. So now let's get into that supplier actually get rated numerically because the topic provides a real formula here rather than a vague criteria. So rating a supplier capabilities involves two things, the supplier system, financial, manufacturing, and the quality, and the supplier's delivered product. So other consideration factor in these two, like the effort, the time, the cost necessary to replace a supplier, the supplier's ability to deliver the material on time, the geographic location of the supplier manufacturing facility, and how important the material is to the product's own how important the material is to the producer's own product. The rating of a supplier system usually begins with the initial supplier survey we just covered, so often follow a periodic supplier resurvey called a systems audit. So this gives a customer an ongoing opportunity to evaluate the supplier system over time. So any deterioration gets noticed immediately rather than discovered only after a failure. The rating of a supplier delivered product Meanwhile, basically takes the form of recording the results of income inspection and rejections within the customer's own manufacturing process, and can also include failures caused by supplier delivery products and showed up during the customer cycle or while the product was already in service. Supplier rating elements and formulas are generally as diverse as companies are, but the common threads across virtually all of them are quality, price, and delivery. So let's focus on the quality factor first. Since it is shown here on the screen with its actual formulas, the quality lot rating is calculated as the number of lots rejected divided by the number of lots inspected. The quality part rating is calculated as the number of parts rejected divided by the number of parts inspected. Note that this operates a finer grain than the lot rating, since a lot can be rejected even if only some of its parts are actually defective. So these two get combined into an overall quality rating using a weighted formula 0.40 times the quality lot rating plus 0.60. So the quality part rating. So giving more weight to the more granular part level data. The full quality factor in practice usually also falls in comparison with competition, complexity analysis, the economic condition, though the topic does not provide exact weighting formula for those secondary elements the way it does for lot and part rating. So let's finish the rating formulas with delivery, then show how everything combines into one overall number. The delivery factor usually includes a timeliness rating and a completeness rating. The timeliness rating is based on due date of the lot minus some demerit. So this topic is example like is 10% for each day. The lot is early or late. So beyond some specified grace period or window, for instance, the due date plus or minus 2 working days. So there's a generally important logistics here getting the right time. So if the supplier comes the freight carrier, the system can base due to date on the date the lot is received at the customer's dock. But if the customer chooses the freight carrier instead, the due date should be measured by the data shift from the supplier. Because in that case, any delay in transit is the customer's own carrier's responsibility, not the supplier's. So it would not be fair to penalize the supplier for the late dock arrival that they didn't control. The completeness rating is simpler. The number of parts actually received divided by the number of parts scheduled to be received. Now, to build an overall rating, you assign the percentage to each aspect and take a weighted average. So this topic provides a work sample weighting for all three. Delivery rating equals 0.50 times timeliness plus 0.50 times completeness, an even split. So price rating equals 0.40 times a comparison level plus 0.30 times a complexity level plus 0.30 times an economic condition factor. And finally, an overall supplier rating equals 0.40 times the quality rating plus 0.30 times the price rating plus 0.30 times the delivery rating. So quality getting the largest single weight of the three top level factors. So this generic example can be expanded into a elaborate computerized system for a large organization, but it can equally be tailored down for a smaller business that may be still running manual systems. The underlying structure for quality price and delivering each broken into own sub formula skills at either direction. So the purchasing organization usually tracks and monitors suppliers on the ongoing basis, and a special supplier quality assurance group or SQA. It may be formed specifically to work with the buyer and look at suppliers' performance over time. Some common suppliers information track includes defective parts per million or PPM, cost adjustment request, delivery date slippage, performance improvement trends, and adherence to quality requirements. Using metrics like the QIS, Quality Information System, we covered the QMS material. can generate reports such as supplier profiles by whatever selection criteria matter to the organization. Suppliers can be ranked by defective PPM, by improvement trend, or similar metrics, and preferred suppliers can then be selected using the genuine quantitative data instead of guesswork and internal politics. So that last point is worth sitting. Without the solid metrics, supplier selections decisions can quietly become influenced by which purchasing agent has a long-standing relationship with which sales rep rather than by objective performance. So ideally, the chapter argues the suppliers are treated like partners in satisfying the ultimate customers, so not merely as vendors to be squeezed. But this requires a genuinely mature organization with objective information behind. Communication skills, careful fact gathering, and a good QIS are all needed to achieve that partnership model rather than just claiming it. The closing guidance is simple but important. You and your suppliers should keep constant communication open on many fronts to ensure that everything is working well toward the shared goal of delighting the ultimate customer. The same customer-centered framing we spent the entire session on previously, now extended to backward through the supply chain. Let's close out the supplier management material with risk. So specifically, how standards, specifications, and contingency planning work together to protect the organization. Standards and specifications are documents containing the criteria that must be met, and here's the legally important part. So these documents become legally binding by reference on the purchase order. So they define exactly what is being purchased from the supplier and can take from the form of engineering drawings, catalog descriptions, or other documentation. It's worth knowing that the purchaser doesn't always need to develop or original specification from scratch. Commercial quality specification are widely available, ranging from detailed engineering drawings, so which may themselves include references to process specifications such as reliability, verification, and inspection requirements, all the way to the off-shelf items, which are simply defined by their characteristic on the manufacturer's own datasheet or catalog. So these commercial specifications generally help simplify the procurement process since you're not reinventing a specification that already exists and it's already trusted in the market. So here's a critical, legal point for this topic. It emphasizes the applicable standard for specific document actually incorporated into the purchase order. So there's no doubt the requirements are meant to be met. If they are not incorporated into the purchase order, there is no basis for the enforcing compliance. In other words, a spec that exists somewhere in the filing cabinet but is not referenced on the actual PO carries that no legal weight if the supplier fails to meet it. This is a single step of incorporation, what helps ensure business continuity and minimize the risk associated with supplier materials or items. Finally, it's important to include contingency plans, specifically related to supplier purchases. What happens if the supplier cannot deliver, goes out of business, or has a quality failure? So this chapter points out to, in the chapter 7, for the detailed information of risk management generally. So noting that those some same risk management principles applies to suppliers just as much as apply internally within the organization. So this is generally important evidence-based section. So let us set it up properly before diving into the detail. An organization with a properly implemented total QMS will have a fewer non-conformities, reduce rework or scrap. So lower inventory levels, reduce cycle times, greater employee satisfaction, and increased customer satisfaction. Organizations that are not available to overcome the barriers to quality improvement simply will not experience these benefits. The barriers are not a minor inconvenience. They are the difference between getting the full payoff of quality work or not. So this list is not speculative. It comes from a real study. So in a study by Salegna and Fazil from 2000, the managers of total quality management companies were asked to rank obstacle to implement quality, and 12 barriers on screen that are listed in the actual order of the importance of managers reported. So we'll go through the 12 and roughly at four at a time. So, but here's the overview of worth absorbing. First is the lack of time, poor communication, lack of real employees empowerment, lack of employee trust, politics and issues, and a lack of formalized change plan, lack of strong motivation, viewing quality as quick fix, a drive for short-term financial results, lack of leadership, lack of customer focus, and a lack of a company-wide definition of quality. If you notice something important, I'm sorry. So notice something important about the order. The most cited barrier is not technical or statistical problem at all. It's simply lack of time. And the least cited at number 12 is the lack of company definition of quality, which the chapter itself will tell us actually the easiest of 12 to fix. The gap between most and least common barriers tells you something real about where organization actually struggle. So not defining the quality abstractly, but actually protecting the time, trust, and empowerment needed to pursue it day by day. So let's take the top four barriers in real depth. So since there are one manager cited most, number one, the single most cited barrier, lack of time to devote to quality initiatives. Frequently, managers are simply too busy with their regular activities to take on additional activity like quality. So this topic recommends fix has a clear sequence. Initially, senior management must proactively provide a time for employees to devote to the quality initiative. So once a program is well established, though the quality activity becomes a part of the employee's normal everyday activities rather than something extra bolted on. The investment of protected time upfront is what allows it eventually becomes a self-sustaining. Number two is poor intra-organizational communication. So all organizations communicate with their employees in some manner, and those communications deliver the organization values, expectations, and directions, provide information about the developments, and are supposed to allow feedback from all levels. The fix here is specific. The organization must encourage and provide the actual means of two-way communication so information flows up the ladder just as much it flows down. A one-way broadcast from leadership is not real organizational communication. Number three, lack of real employee empowerment. This topic is blunt, and empowerment is merely a lip service. So, rather than in a loud meeting, but not actually granted in practice. Individuals should genuinely be empowered to make decisions that affect the efficiency of their own process or the satisfaction of their own customers. And critically, teams need proper training and at least the beginning of a facilitator, which ties directly back to everything we covered in the facilitation material. Empowerment without the skill to use it well just creates chaos. So number four, lack of employee trust into senior management. So this topic offers a genuinely reassuring nuance here. In many organizations, this obstacle simply will not be a problem because senior management has already created the atmosphere of trust in its relationship with its employees. So in organization where trust is lacking, though that the atmosphere has to be deliberately developed and the mechanism given is straightforward. Management being honest with employees consistently over time. So continuing with the barriers, 5 through 8. Number 5, politics and third issues. So difference between the departments and between the individuals create a real problems here. So this topic recommends remedies. The use of multifunctional teams helps break down long-standing barriers between groups, and in some cases, restructuring the organization to be more responsive to customers' needs and generally be required. The specific example given is the use of product or customer support teams, whose members are permanently reassigned from quality, production, design, and marketing. So not just borrowed part-time, but actually moved. which removes the whose turf is this questioning by design. So number six is lack of formalized strategic plan for change. A formal plan is necessarily precisely because individuals, resist change. People become accustomed to performing a process a particular way, and it becomes the preferred way simply through habit, regardless whether it's actually best. So this topic gives three basic concepts of change. Change management must understand. People change when they want to, and to meet their own needs, not because they are told to. Never expect anyone to engage in behavior that serves the organization values unless an adequate reason, like a real why, has been given. And for change to be accepted, people must be moved from a state of fear to a state of trust. It's difficult for individuals to change their own behavior, and it's much more difficult for an entire organization to change collectively. Honest, like two-way communication with respectful feedback increases that the chances of success is there. So number seven is the lack of strong motivation. So this topic is frames building a motivated workforce as for the most part as an indirect process. So management at all levels cannot directly cause an employee to become motivated. They can only create a conducive environment in which the individual become motivated on their own. Number eight, the viewing the program as a quick fix. So this is generally common in managing misperception. Quality improvement is described vividly as a race and does not have a finish line. Management and must the management must constantly and forever improve the system so the quality and productivity are continually and permanently improved and costs are reduced. So there's no point at which the organization get to declare a victory and stop. So finishing out the list of the barriers, 9 through 12. Number 9, a drive for short-term financial reserve. Too often, organizations focus their efforts on quarterly financial results specifically at the expense of the longer horizon thinking. So quality improvement, by contrast, requires an organization to have a strong future orientation and a genuine willingness to make a long-term commitments. Investment that may not show up favorably on these quarter numbers at all. So number 10, lack of leadership. For any organization effort to succeed, there simply must be a leadership behind it. And this topic, it specifies that this requires a substantial commitment in terms of both management, time, and organizational resources. So not just a supportive memo from the top. Number 11 is the lack of customer focus. So this connects directly back to the entire session on the customer relations. Like organizations need to understand the changing needs and expectation of their internal and external customers. And the effective feedback and mechanism are described as the necessary for the understanding to actually develop and stay current. And number 12, the least cited of all 12 barriers is the lack of company-wide definition of quality. So this topic is refreshingly direct. So the obstacle is described as the least of the 12 and it's easy to correct. Experienced quality professionals recommend that all areas of the organizations be involved in the writing definition together. So rather than having it handled down from a single moment or a single department. So the act of collaboratively defining quality itself, it's part of the what makes the definition actually stick across the organization. So it's worth noticing now that we've covered all the 12 in depth, like how the list moved from the hardest, most structural barriers, like time, trust, and empowerment politics, towards the softer, more easily fixed ones at the bottom. So that ordering itself is a useful diagnostic. If your organization is struggling with the barrier 12, so that's generally an easy fix. If you're struggling with the barriers 1 through 4, you're dealing with something much harder to shift. But there's always have a chance. So how do organizations actually overcome these 12 barriers in practice? So this topic is honest and it can be difficult, but offers a real guidance. Some ways of overcoming the barriers are generally like self-explanatory. The example given is direct. So if there is a lack of leadership in organization, especially leadership interested in quality, then change simply would not occur unless new leadership is established. No amount of clever technique substitutes for that. For barriers that are not quite binary, this topic points to formal change management, centered on the concept of change agent, defined like citing Blair Robbins and Judge 2025 as someone responsible for managing change activities. So change agents can be successful when making changes regarding structure, technology, physical setting, and people. A generally broad remit, a change agent who is specifically interested in improving quality in an organization can be very effective at dismantling the barriers we just walked through, precisely because they're focused on the driving the change rather than just identifying that it's needed. So this topic closes with a concrete work example, like tying back to the barrier number one, specifically to overcome a lack of time. A strategic process for selecting quality projects should be implemented and supported by the leadership, and time supporting quality projects should be built directly into employees' workday. So not squeezed in around existing commitments, but structurally allocated. And here's the connecting thread worth ending on this. So this type of strategic planning is described as a fundamental principle in many continuous improvement methodologies, including Six Sigma, which means overcoming barrier one is not a separate. So standalone fix, it's built into the DNA, same improvement methodologies we've been discussing for the entire series. So let's bring both of this session by having a five close points. So first is modern supplier quality management is fundamentally about preventing defects upstream. So rather than catching them downstream through inspection. So the whole history arc is from the wasteful old model through MILQ 9858 and BS 57550 to today's AIAG PPAP and AS 9102B. So it's a story of pushing quality assurance earlier and earlier in the process. Second is survey, audit, and inspections are genuinely distinct tools, so not interchangeably synonyms. A survey happens before a contract exists. An audit happens after one is in place. An inspection examines the physical product or a lot itself. So knowing which tool fits which moment in the supplier relationship matters. Third is supplier ratings turn quality, price, and delivery into one defensible weighted number. The specific formula we walk through from a quality lot part ratings to the overall 0.40, 0.30, 0.30 weighting replaces the guesswork of internal politics with the data that can actually be defended and compared across suppliers. Fourth is the barriers that most commonly stop quality improvement are not technical at all. So they're about like time, trust, and empowerment. The Salegna and Fazil study rank a lack of time as the single biggest obstacle, well ahead of resembling a lack of statistically like know-how and lack of shared quality definition. The most technical sounding barrier on the list actually rank, the dead last. And fifth, a dedicated change agent combined with the time generally built into the employee's workday rather than the squeeze around it. So it is how these barriers actually get dismantled in practice, not through inspiration alone, but through the same kind of deliberate strategic planning that underlies the Six Sigma and every other continuous improvement methodology that we've covered. So that closes the supplier management and the barriers quality improvement. So happy to go deeper on any of the rating formulas to the 12 barriers if that would help. So I hope you enjoyed the series of the leadership and management for this quality engineer. And I'll see you for the next series. Bye bye.